Let me quickly make sure we're live. I always mess up sometimes. Awesome. I think. No, not yet. Now I can hear myself, which means we're good. Welcome, everyone. Thanks for joining us. I know you're not here to listen from me, so I'll shut up real quickly after introducing Movie. I don't think anyone needs an introduction to Move. She leads the. She was just telling me she works on the entire Keras ecosystem in Transformers repository. I'm sure everyone knows what Transformers is. If you don't, it's the Hugging Face Transformers we're talking about. She also has this intersection of a developer advocate role at Hugging Face. She does a lot of community stuff there and is also a Google Dev expert. Basically, if you do anything remotely related to NLP, Hugging Face, or Keras, you would know Merve. So she'll be telling us about how to get started in Transformers using Keras. I had promised everyone we'll try to get great speakers to give you great workshops. So I couldn't have topped it. And with that, I'll hand it over to you. Thanks for joining us, Move.
Thank you for the kind words. It was great.
I've been waiting a long time for this workshop. I know I have delayed it a lot because I was going back and forth, but I'm excited to learn from you today.
Thank you so much for this kind introduction. So today we are going to see the using how to use transformers with TensorFlow Keras. And about me, I'm a developer advocate at Hugging Face. I'm basically maintaining the Keras ecosystem at Hugging Face, as well as we have a separate thing for the TensorFlow transformers. And I'm also doing community work. And I'm currently an NLP researcher on morphologically rich languages. And previously, I was working as a machine learning engineer doing natural language processing. So I think you have already been through transfer learning in the Keras book, but let me explain this quickly. So basically, in the current paradigm, we have something called pre-trained models, and pre-trained models are imagine a company has basically trained a very big model with petabytes of data. It can be BERT, GPT-2. The most famous ones are those. There are also stuff for the image as well. And instead of starting from scratch, like a traditional machine learning application basically gets trained from scratch, you build, for instance, sequential or a functional model, and then you give your data and you train it. So instead of doing this, what we do is we get a pre-trained model and we put a classifier layer on top of it depending on our problem, and we train it again on our own data. This is called fine-tuning. We tweak the weights and we transfer the information from that big model to our own application, basically. So this is something that has, I think, started with BERT. So BERT is this model that is used for mostly the understanding related tasks. By means of understanding, I say, for instance, sentiment analysis, assessing the sentiment of a sentence, or like question answering, extracting an answer from a question, and the context information that we look for the answer from. So basically, this is how it is done. We take this big model, we put a classifier layer on top, we train it on our own data, and voila. And this whole process is called fine-tuning, and I will go through how fine-tuning works, and we will have an example application today on we will basically train a sentiment analysis model using Hugging Face transformers, TensorFlow Keras. We will track our experiments with weights and biases, and finally build a demo with Gradio.
What's your
So,
favorite model? What's your favorite transformer?
what's my favorite ensemble?
No, transformer. What's your favorite
Oh,
transformer model?
transformer. Okay, definitely BERT. Because I feel
Bird?
like, yeah, BERT. Because BERT is more predictable compared to generative models. And I've
Hmm.
always worked on, understanding tasks mostly, information retrieval and stuff. So, and I really like the idea of the fact that, you have this. I was showing the diagram, but yeah, let me go through it.
Sure.
This idea of masking a word and predicting it and just getting the whole language modeling distribution is so smart. And also, invert one sentence, like we have another thing called next sentence prediction, which we can do tasks that involve sentence pairs. Like, for
Hmm.
instance, NLI, I will show today something like, NLI. You take two sentences and you say, hey, there is a contradiction between them. So this next sentence prediction thing enables us to do fine tuning. I feel like these two ideas that BERT is based on is incredibly smart, and you can just, now take a BERT model and train it easily. It's crazy.
I think Thomas said at some point it's also very cheesy, right? Because it was trained on like some Shakespearean test, so it like chucks out poems if you try to poke at it sometimes. Yeah, sorry,
Yeah,
sorry to derail the conversation.
nice. Okay. But I just love BERT, it's just, I love it more than any other model like GPT and, maybe T5. I also like T5, but BERT is my absolute favorite.
Okay.
I'm such a geek sometimes, it's just weird, I just sound very off sometimes. So, like, yeah.
No, this is awesome. Please continue. I'll shut up.
So basically, what we do in Hugging Face is that we have these big models, and also we have models contributed by community. Like, community goes to Hugging Face Hub, takes the bird model, trains it on their own data, and then they also push it there so that other people can use it. It's just like, a marketplace of machine learning models that you can actually use. Most of the time, you don't even need to train a model from scratch. So this is how the model section of Hugging Face Hub looks like. We have other sections for data sets and stuff as well. And we provide the tooling for the, also, by the way, these are open source. We provide the tooling of the fine tuning process with our two libraries, open source libraries called transformers and datasets. We also have datasets, and these are backed by, your favorite frameworks, TensorFlow, PyTorch, JAX, everything. So you can just go into the hub, take your model, and just, fine tune a model using a data set from data sets, or, like, you can use transformers in the process, which we will do today. And, like, let me go through quickly. Do you have a question, Sanya?
I was just going to add, it also integrates Transformers really integrates well with weights and biases also. So we have
Yes.
like a single line of integration for those who want to track their experiments.
Yeah. Which we
So
will see today.
yep, we'll be seeing that. I'm too excited, so I'll keep jumping in here and
It's
there.
fine.
Please continue.
And it's like, most of the time, like, you don't, as I have told you, you don't even need to do this for the you don't even need to, like, train from scratch. If you think a model is good for, like, you went to Hugging Face Hub and saw the model is there, and you have read the model card and seen that it might be useful for your use case, you can just, call the pipeline on that model, and just, use the model right away. And we don't do only NLP anymore. We have audio models, we have image models, computer vision models, and you can use, there's a pipeline for those as well. So let's see them quickly in an action. Like, there are few of the use cases that I would like to mention for NLP, like maybe something you could use in the industry. So one is this, for instance, you have questions your customers are always asking, okay? And you have this very big document that contains answers to your questions. You can just embed like a question answering model in your own on your website, or like you usually have it serving somewhere else and send a request. But anyway, um, you can basically have this question answering model and have your own document, and questions are coming from your customers, and you can search for that questions answer in those documents and just bring the answer back to the customer. This is something you can do with bird fine-tuned on question answering. Another thing is, like, for instance, you have your invoices, okay? And these invoices, you can get names, addresses, organization names, etc. You can automate information retrieval from those invoices using token classification models. This is actually called named entity recognition, because you are trying to get the named entities. But the whole abstraction over the task is called token classification, because you're trying to predict what a word corresponds to. Is it a name, or is it not a named entity? Things like that. And you can have some fun side projects by like, you can create a conversational agent that speaks like your favorite movie character. I actually tried it on Darth Vader, but realized that in Star Wars there is not much dialogues actually. Like, you can take the script, the conversation turns in a movie, and then fine tune Dialogue GPT based on it, and it will speak like your favorite movie character.
Who's even watched that movie? It's like so many of them are there. I haven't even watched the series.
Yeah. It's just a fun side project, nothing serious. It might come up as biased as well, so don't put anything like that in production and use on your own, use on your own risk. And like, for instance, just an example of a simple pipeline is like, you have a question and the context from what it seems it's like a Dungeons and Dragons game. Adventurer is approached by a mysterious stranger, blah blah, and you have the question and it extracts the answer from that question. And this is done by a couple of lines, just a few lines. You have question and your context, and you call the QA model pipeline. And if you don't give any model from the Hugging Face Hub, in Hugging Face Hub, models have identifiers. If you don't give any model, it will be initialized with the bird for question answering. And you can just infer using, giving your question and the context, and just get the answer. And this also works with TensorFlow Keras, so that's what I was going to elaborate on. So basically, this is a very simple like code snippet. You might not understand anything, might sound like an alien language, but we will go through it during the workshop itself. So just to say that you can train a language model from scratch using TensorFlow Keras, and it is just like native Keras. Like, you define your learning rate, weight decay, optimizer, and compile your model and just call model.fit. There is a couple of pre-processing steps before that, but this is roughly close to the your average workflow in Keras. And you can also fine tune on a downstream task, which is what we are going to do today, and it is just like native Keras again. And also, I will not go through it today, but you can also serve. Like, you can take a model from Hugging Face Hub and just serve using TensorFlow serving if you want to use them in the TensorFlow extended, like, TF Lite, TFJS. You can basically use anything. Like, they should be relatively small though for the light models at least. You can even do like, because Hugging Face Hub provides the encapsulation behind the conversion from PyTorch to TensorFlow and TensorFlow to PyTorch. You can even take a PyTorch model and save as TensorFlow Keras saved model format and just serve on TensorFlow serving, which is I think it's very cool because otherwise you would have to take a PyTorch model, convert to ONNX, and then from ONNX to TensorFlow serving, which is like a cumbersome thing, but only 2 lines. You just convert from PyTorch to TensorFlow. Do you have any questions?
I was going to say we'll try to get Merv to teach us about productionizing. If she likes me as a host, he'll come back and teach us. If not, we won't see her again.
I mean, of course, I would love to do that. Like, we can do like another workshop, and I could like show you how to do this with Docker and TensorFlow serving, if it's okay. That
Totally.
would be great. But I'm not like the best. Just as a disclaimer, there is like so many people in Hugging Face doing amazing stuff over optimizing stuff in production. So I'm not the best, but I am like I know a couple of tricks and stuff. And also, like the most kerasy thing is that like if you want to host your model on the Hugging Face hub so that other people can use it or your teammates can directly pull and use with a couple of lines of code, you can just push your model using push to hub callback, which is just another TensorFlow callback that we have written, and it syncs for every epoch or every step. It just syncs the model with the model on the hub, like the repository on the hub, which I will show you today. And also, if you define the TensorBoard callback in this callback, or like if you want to later push using Git, you just need to like pass your TensorBoard log directory, and we will host them on the hub for you, which is a bit cool. And lastly, if you like these all of these apply for the transformers models that are based on TensorFlow. But we also host the Keras models, like regular Keras models that are not transformers. So if you want to do that, we have written this function that basically takes your model and pushes your model to the hub. You can also push your TensorBoard traces, and we will host them for you. And yeah, if you'd like to learn more, I'm going to show the notebook now. But we also have like a course that goes through all of the theory, the tricks. There are notebooks, like everything that you need. You can also reach out to me from this email. This is it for the presentation part, and we can get to the notebooks if there is no questions.
They're just Star Wars references which I absolutely don't understand. Someone says Obi-Wan talks a
Wow,
lot.
thanks a lot. Yeah, I have definitely picked the wrong character to build DialoGPT on. There
I
is
haven't
like,
watched the movie.
especially in the 4, 5, 6, there is so little number of dialogues. It's all, other stuff. For the first 3, you have just very little number of dialogues.
I also wanted to mention we're also hosting a study group around the awesome Hugging Face course. So if anyone wants to check that out, they're also welcome
I
to join that
didn't
group.
know that. Seriously, that you are going to do Hugging Face course?
We've been hosting it every Sunday for a while now.
I should just come over. I will just drop down. This is awesome.
Please join.
Let
Maybe
me
we'll do a third workshop there.
Yeah, sure. Let's do it. I'm going to definitely reach out to you, and we will plan this. I'm
I'll
gonna
I'll get I'll upset Julian and he'll say I'm pulling you in for a lot of work.
No, it's fine. He would be more than happy. Otherwise, I would be bugging him with others. I wonder if
Pe-
he's listening, by the way. Like,
People are saying
whenever
that sounds fun.
sometimes Julian drops by to, talks and stuff, and it makes me incredibly happy.
Yeah, he's awesome. Could you please zoom in a bit for the
Yeah,
coding?
sure. I'm going to zoom in, but let me like I'm going to first go through the nature of understanding tasks and everything in
Please.
here, if it's okay, and then we can get to the other code parts.
Mhm.
So so basically, all of the NLP and also computer vision goes with the, like improves by the benchmarks. And these benchmarks are data sets. So basically, whenever someone trains a model, they just use these benchmarks to test if their model is state of the art or not. There are a couple of benchmarks. One is glue benchmark, and this is for the understanding tasks. And we also use this to fine tune our models on understanding tasks, like, BERT models mostly on understanding tasks. And it's a family of tasks, actually. There is not only one task, but it's a family of tasks that contains, all of them are about classifying a sentence. It just, the only thing that changes is the purpose of that task, basically. So we have, for instance, corpus of linguistic acceptability, which is like assessing if a sentence is true, grammatically true or not, grammatically appropriate, acceptable or not. And these are all hosted in TensorFlow datasets and also Hugging Face datasets. But TensorFlow datasets has like big, how can I say, like explanations for everything. And I'm going to show you. So for instance, the default config for this is COLA, which is like corpus of linguistic acceptability. And let me show you quick examples. Like, for instance, a sentence, I broke the twig of the branch is an acceptable sentence. So it is labeled as one. And, one corresponds to acceptable in this case. And then unacceptable one, the inspector analyzed the soundness in the building is unacceptable, for instance. A couple of other examples that I think are cool is, for instance, we have Quora question pairs dataset. And I have previously used it in my previous jobs to augment the, frequently asked questions in my training data. Like, I had to deal with frequently asked questions. And I basically use this model, use this data set to fine tune a T5, and then I have basically paraphrased questions that had the same meaning but were different, so that my training data was a little bit more diverse. So the examples are, for instance, we have how can I become rich in short time, and how can I become rich man are duplicates, so it's one. And there are other ones that are not duplicates. And we have, for instance, QNLI, which is another cool thing. You can use this to, I'm going to explain the task first and then tell you the use case for this. So we have questions and sentences. And this model, this data set has basically questions and the sentences that might contain the answers to those questions or not. And if it contains the answer to the question, it will return 0. And if it's not, it will return 1, which is a bit confusing in my opinion. But yeah, you can use this to extract information from papers, like iterate over every piece of text in a document, and then just, get the, potential text that might contain answer to your question, which is, I think, works better than question answering models, because you also have the context, and thanks to this context, you can see if the question is actually answered or not. And today we are going to go through the Stanford Sentiment Tree Bank 1, which is a sentiment analysis data set. And it has sentences and 2 labels, positive or negative, and according to their sentiments, basically. There are different variants of this task, by the way. One is aspect-based sentiment analysis. It is like, let's say, I really like this product, but the price is too much, so I wouldn't recommend that. But the quality is very good. So you cannot really put this in positive or negative. So it has different aspects. Like, for instance, it has a price aspect. It has a quality aspect. So you try to assess it across different aspects, because nobody says, oh my god, this is incredible product, I definitely recommend that. I mean, it's rarely the case. People usually look at one product in different aspects. So and there are like emotion data sets that contain, like, for instance, you have movie reviews, and there is, like, anger, I don't know, happiness, etc. Like, and how we solve it is that we have this BERT model, and let's say you have 5 emotions in one data set. You basically put a classifier layer of 5 output units, and then you just do the fine tuning, which performs better than a model that is trained from scratch. So you basically do this, like, we have all of these data sets for understanding tasks, and we use them to fine tune a bird and accomplish our task. In Hugging Face Hub, by the way, I'm going to, let me do it like this. You can basically get this with text classification. Because it's a text classification task, you will find all of the glue tasks under one category. We have multiple sentiment analysis tasks, and we also have them across different languages, because people also have these glue tasks across different languages as well. For instance, we have one for Turkish. There is many for them. Anyway, let's go back. So today what we are going to do is we are going to take a bird, and then we will fine tune it on our glue, one of the glue data sets, which is Stanford Sentiment Tree Bank. And then we will build a demo, and we will track our experiments using weight and biases. For this, there are necessary packages you have to have, except for the Hugging Face Hub. We are having this Hugging Face Hub because we want to push our model and get it hosted in the Hugging Face Hub. And if you don't want that, you can just use the 3 of these. And so we have to, for me to track my experiments, I have to log into weights and biases. So I have already did this. I don't want to run this notebook from scratch because I will have to train a model. So I will just go over the code itself. There's an explanation on the family of the glue tasks here, and we will have a key for this task, sentiment analysis. It's called SST2. The name comes from the data set itself. So in here we have SST2, as you remember. Any questions?
I was just going to mention to anyone who signed up, we'll email this collab to you. So please don't worry about not seeing the link.
Cool.
Please continue.
Okay. And we are going to get this model from Hugging Face Hub, which is Distilbert based uncased. Distilbert based uncased. So basically, Distilbert is a BERT variant that is smaller but has an equivalent performance with BERT. And I think it's cool because not everyone has the luxury to train a big BERT model. So instead, we can just take a Distilbert and just train it. So if you want to use a model from Hugging Face, you have to get this identifier and just pass it to the transformers. And we define our batch size here. And we are going to load our data set from Hugging Face datasets. It is backed by TensorFlow datasets, by the way. So let's see our dataset. It is under glue. And this glue has multiple tasks, and each task has splits. So when we want to load the SST2, we pass firstly the task itself and glue itself, and then the task. So we load our data set like this. And then, so each model, I don't know if you have gone through this section in the book, but we have for each model, we have a tokenizer that, gets the sorry for the corgis, by the way. They have roses because it was Valentine's Day and they left it open for the single people to suffer even further. So for each model has its own tokenizer, and these tokenizers have, like, they split our text and then maps it to some numbers that model can understand. So we load our tokenizer by passing the model itself, which is Distilbert based on case, to auto tokenizer. So, what this does is that it goes to the model and finds the tokenizer and brings it to us. And for instance, it's when we pass, like, we can pass one text or multiple texts to a tokenizer, and it's going to map these to the map them to the numbers. And for instance, let's see an example from the data set. So we take the first example from the training split and see the sentence, hide new secretions from the parental units. This is an example. And to tokenize our data set, tokenize our training data, we have to, like, we have written this pre-processing function that we can pass the data set in, and then it is going to tokenize our whole data set. And why didn't we directly do this? The question is. So there is something called map method of data sets, Hugging Face data sets. So whenever you use a data set from Hugging Face, you can call map, which is going to apply this pre-processing function to your data set and batch. And there is a couple of other stuff you can do to increase the performance of this. I'm really sorry about it. Let me try to stop the corgis. I
think they meant
honestly
it as a
don't.
joke. I think.
Oh, it's a joke. I am sorry if it.
No,
This was
I think this person meant it as a joke. Please make it stop as a
okay.
joke.
I honestly don't know where to shut the corgis down.
Yeah, they can't be stopped. They're
They can't be
unstoppable.
stopped now. They have invaded my corner. So
Please continue.
sure. So basically, we get the we basically pass our pre-processing function, like we apply it to the whole data set here by calling datasets.map. And lastly, we have something called data collator, which is going to group each batch of samples together and apply some pre-processing on this. Like, for instance, for this one, we need to pad the examples to batch them. So we call data collator with padding. So there are different data collators for different tasks, but for the text classification one, we have this one. And we pass our tokenizer, and don't forget to set this to return tensors to TensorFlow. And lastly, so basically there is something called tfdata.dataset, which is like the dataset object that Keras models accept natively. And if you want to use this, like if you want to use this, you can directly call to TensorFlow dataset from Hugging Face, which is going to convert your data to TF dataset, which is more convenient to train the model. And for this, we call this with the tokenizer columns added by the tokenizer, which are like listed here. I think I passed it, sorry, but they are like input IDs and attention mask. And we set the label column, and we set shuffle through the batch size, and we pass our data collator inside, and this is going to return TF dataset, which we can directly pass to model.fits. Very convenient. And lastly, just like any other Keras model, we will define our loss, which is sparse categorical Keras entropy for the classification. Like for all classification, you can use this, and just It's just the same with the, text classification problems. And we pass the number of labels. So basically, we will call our model. That's why it's important, and I will explain what is being done. So bear with me. So when I call TF automodel for sequence classification, so think of this as like a model structure for, model class for TensorFlow transformer models in Hugging Face. What this basically does is that it takes the model weights and it puts a classifier layer on top with the number of labels, so that, let's say you have 5 labels in your data set. It's going to put five five output units for the classification task. So basically, I'm taking the BERT model, and then I'm putting a classifier layer on top, and then I just fine tune. This is what is being done over here, actually. And the same class exists for PyTorch models. And if one good thing I have mentioned previously, but again, if for a specific task, let's say sequence classification, if I have the TensorFlow architecture and if I have PyTorch architecture, these classes, then I can convert one weight to another. So let's say you want to use stuff from TensorFlow ecosystem. You can take PyTorch models and call this, for instance, call this and say from PT equals true. And you can just, take that PyTorch model and convert its weight to TensorFlow and use anything you want in TensorFlow, which is incredibly nice, because then you don't have to deal with, it's just one line of code, and you don't have to do with ONNX or, trying to convert the weights yourself. And lastly, we call Adam Optimizer from TensorFlow Keras and compile our model with the optimizer and loss. I'm going to get to these, but let me quickly go through the model.fit. And I will just call model.fit somewhere over here. So this is the main transformers workflow where it is done. But I will just add things to improve my workflow, reproducibility, and improve the collaboration. So to do this, I'm going to go through that.
Okay.
Is there a
Sounds.
problem?
No, I was
Question?
just going to mention the callback.
No, I will go through all of the callbacks. Don't worry, we will
Okay.
spend a good amount of time.
I trust you. Okay.
So because I want my model to be hosted on Hugging Face, I can just, because we use Git large file storage system, I just get the necessary script and the installation for the Git LFS in these 2 lines. And then I just call git lfs install to initialize git lfs in the directory I'm working on, so that git lfs will track large files in the directory I'm working in. And I'm going to call Hugging Face CLI login, and it redirects you to your token page. And I have my tokens over here with different access levels. And for, pushing my model, I have to call, write one. And I just log in here so that I can say, hey, this is my model. Can you just push it to the other end? And I'm going to initialize weights and biases, just pass my username and the project name. I have already trained my model, so I'm going to show you the logs. And I just pass the config, and I call weights and biases Keras callback to, track my experiments. And so another cool thing I have previously mentioned is push the hub callback, which can push your model to the Hugging Face hub. And I will tell you how to do this. And you can also call TensorBoard, which can just send the TensorBoard logs and host it on the repository. And for this, I initialize it with the output directory of the model. And the model ID I want my model to be hosted in, which is basically this. It creates one from scratch, and if you already have a hosted repository for your model on the hub, you can also pass the repo URL, which is another like argument here, but I didn't do that. And I have to pass my tokenizer so that auto tokenizer can find my tokenizer if someone else wants to use it. And I am going to define, so another cool thing, we have this callback called Keras metric callback, which you pass a metric computation function inside and your evaluation data set. And it's going to calculate metric at every epoch and tell you what that metric is. Because in most of the NLP problems, in this one, we have accuracy. But in other NLP problems, we have scores like rouge or bleu, which are calculated differently, and you have to intervene into the training loop with the tokenizer and everything. That's why we have written this, and this is like, we have written this with Matt, the TensorFlow maintainer, and this was one of the one of my first PRs in the Transformers TensorFlow, so I was quite proud of this. Anyway, we have the metric function and the evaluation data set. And for this one, I just used accuracy, which is like a very simple metric because it's a classification task. Also, this metric.compute is coming from the Hugging Face datasets library. It just computes the metrics given the predictions and the labels. So I'm going to pass so many callbacks into this one: metric callback, weights and biases callback, and push the hub callback. And I have, when I call model.fit, basically I give my training data set, validation data sets, epochs, and the callbacks. And this is going to train. And as you can see, at the end of every epoch, I have the accuracy here. I could
This
have
might be a
had.
good time to show the dashboard, no? If you can click on
Yeah,
the
yeah,
log
sure,
runs.
sure. So I'm already hosting it. Like I have already pushed it. So I have this. I don't know how to talk about this curve.
I can talk about it. So
Yeah,
the
sure.
first thing I like to do is I like to judge people on their graphic cards. So like I go to their runs and see their system settings, and then I see if they're using Colab or just a CPU. That's also tracked. So when Merv used a won't be Keras callback, that means that there you go. You can see the
Would you like
graphic
me to
card.
go up?
No, I was just looking at the graphic card and trying to figure out which one it was.
Okay.
As I was going to mention, we integrate well with all of the frameworks. So when Mo sent in the callback, it all automatically captures a lot of things. Like you could see the system usage, which is like my lazy way of benchmarking the code. People say you should benchmark it while writing it. I just log everything to weights and biases, and then I can see, oh, maybe the GPU usage isn't at 100%. I
I
need to
don't
like,
judge you for this. I'm just saying.
sorry.
I don't judge you for this. I'm not
I mean,
doing.
it works, right? It's the
Yeah,
same thing. No one will know. Now they do, but apart from that, you can also see like all of these runs. So I believe Merv, you run
I
two
have like
runs.
multiple runs. Yeah, I have trained this previously.
Yeah, so you can see the different plots up above. If you scroll up,
Yeah.
you can see. I think you interrupted the second run, so that's why we just see one plot. Ideally, if you run like usually people run 300 400 runs, so you can visualize all of them together. That makes life easy because then you can go ahead and select just one that you really want to look at, stuff like that. On the
So nice.
left, if you click on the broom,
Blue.
the broom, sorry, if
Oh
you go
yeah,
back,
here.
so that's a hyperparameter sweep, and when you click create sweep, we can also suggest some parameters, and if you scroll down,
I think yeah.
if you
So
click
I
on
don't
initialize
like,
sweep,
yeah.
so we do some Bayesian stuff and automatically suggest some hyperparameters. You can change that stuff, but you can just copy this one line. And now, if you have like multiple machines, you can just drop this line everywhere. And weights and biases will take care as a central agent will take care of your multiple agents across which you can run hyperparameter sweeps as well. So your uh, Obi-Wan will have optimized dialogues through that.
This is really cool, actually.
Yeah, if you run a hyperparameter sweep, right, the plots that come out of it, I really like staring at them. So that's another thing that I think a lot of people in the team do.
That's the most geekiest thing I have ever heard from someone.
I was tempted to tweet day before yesterday the models I get and like a, a log, weights and biases log image. Yeah, that joke didn't say it. Anyways, please continue.
So, because I have called the push to hub callback, my model is also on the hosted on the Hugging Face hub, which means I can just call it with the pipeline or inference API. Pipeline basically downloads the model, and then the model puts a tokenizer at the beginning of the model, so that you put an input text, and then it goes through the tokenizer and it goes through the model, and you get the prediction, which is really cool because it saves you from a lot of hassle. It's like a box that does everything for you. And in the pipeline, there is also something called, we have like our model configurations, and in model configurations you have label to the ID and ID to the label. For instance, like in here, like positive maps to 1 and negative maps to 0. We need to keep this because your model usually doesn't say, hey, this is positive. It will say, I think like with 80% probability this is 0, and you will just take the argmax over all of the results and get the mapping from that result to the label itself, which is negative. This is already done by the pipeline itself. And as I have told you, my model is hosted here, which is really cool. And there is a hosted inference API, which is like, I love this. I love weights and biases, let's say. My model is poorly trained. I trained it for only 4 epochs, so it is actually really, it's not going to perform well. But let's see what it does. I can just test this model right away here. And there is usually a cached example, and for the examples that are not cached, it's going to load the model again. So we will wait for it, but let's go through this.
We
You can
have
also
a legend in the YouTube chat. Abhishek has joined us. Just wanted to shout out his incredible YouTube channel. He's a 4x grandmaster, and I don't know how many things he does.
he's just an amazing person that does everything in one place. He has this big community, he has this YouTube channel, he does awesome tutorials. He's so underappreciated in my opinion. He's also doing
Abhishek,
millions.
I Abhishek, I gave you a shout out. Please send me a 3080 Ti now that you're hosting.
Yeah, he's also doing competitions and stuff. It's just crazy. Anyway, so basically, I can call pipeline on this. I call the text classification pipeline, which is the abstraction over all of those glue models, because you do not need this for every single split. You can just say this is a text classification problem. And you call your model like this. You give your model as a argument, and it's going to download your model and build a pipeline over it, and you can just give your input, and this is going to say it's positive. It's actually positive, but I don't have the necessary labels for this just maps to positive, and you can just know that, and the score of this, which is really convenient to test your models. and we will see how to build the UI over this. So I basically install Gradio, which is a really good library to build your UIs, and I import Gradio as GR. So basically, thanks to the integration, you can just call gr interface.load, and you can give your Hugging Face model by prefixing your model as Hugging Face. Otherwise, you have to like define every single thing, Gradio interface, give your model here, give inputs, I don't know, input type, which is like text box, output type, which is like another, I don't know, label, etc., etc. But because this knows that this is a text classification model, it will just say, hey, if this is a text classification model, I can just put the text itself, put a text box and the labels like this one, and just like create it for you, and not let you do everything. But like otherwise, if you have a regular Keras model, you can just do it like this. And I can define examples to hint the user, saying you can pass this, you can use it like that. And the couple of other stuff, like I have the title of my demo, and which is here. I'm sorry for the theme, I just love this synthwave theme a lot, and I should have changed that. And I have the description of the demo, and I just call launch, and it will launch it for me. So basically you have a UI, and you can even host it on the Hugging Face spaces for everyone else to play, which you have probably seen with the anime gun and VQ gun and other cool stuff Ahsen has built so far. But yeah, it's just so easy to build like a demo for like 3 lines of code, because when I was a machine learning engineer, oh my god, like for only internal demos, I would spend a day or so, because I wasn't a backend developer and I didn't know like how to build a UI, like use everything like Flask, I don't know, serve it with like requests and stuff like that. It was just so hard, do serve it on ngrok. Like I just don't like it. Okay, and I feel like no one has to deal with this. You just need to focus on the things that are important for you as a machine learning engineer, which is like optimizing your model and making it better, and not building a UI over it. So like in the I didn't build a UI for this, but I have a ready to use one. Like I have built one for question answering, for instance. It's just served here and your team members can see it, and you can also, only your team members can see it if you set it to private. Like for instance, I have this text and I have a question, and I am returned an answer, and this is again done with just a few lines of code here. Gradual interface load, blah blah. So also, like, just a quick shout out. We have a Keras working group at the Hugging Face. If you'd like to join us, what we are doing is basically we are getting all of the examples from Keras.io, which you love, and we serialize those models and build demos over those models and just host it here, so that anyone who is looking at a cool Keras example can find the model here, for instance swing transformers, and here there is a space. But yeah, let's go to swing transformers first. You can just pull the model and use it yourself, instead of going to Keras.io and getting the notebook and then training it. And also we have spaces for this, and currently we are doing a sprint, which is like for the win, like Keras, reproducible Keras for the win. So we try to reproduce those Keras examples and letting the community test them. If you'd like to join, it's a cool thing to do. And this concludes the workshop, and you can have questions.
This was awesome. Thanks for the rundown, and thanks for walking us through every single detail. I'm sure everyone loved this. I'm sure this wasn't for me, but Leon said this, so he was happy to see you and Abhishek. Thanks, Leon. There's a question by Ahmed. Let me copy paste it here. 1 second. And I'll highlight it in 1 second. So they're asking, I want to modify one of the, this is unrelated to the workshop, one of the machine translation models, not fine tuning or adding layers. How can they do that and train the modified model with modifications from scratch?
I think if you already have the model class, I will also share it here. Let me share this to hf.co, join Discord. If you already have the model class itself and you just want minor changes on it, I think you can do that. And just take all the model architecture and just modify it and use it on your local instead of calling it every time from transformers. But this is just a wild guess. I would probably do it like that. You can also we also have a forum you can ask questions from. Let me send you the link. You can get better insights over there.
Thanks for that. Awesome. I'm just checking if there are any other questions. Someone says really nice presentation. I enjoyed it as well. So thanks, Merve. Could you share link to fine tune GPT J2 or Neo? Any idea when Neo is releasing on the hub?
Let me check for a sec. So I will share a generic link for all of the Hugging Face examples, but these GPT-J and Neo, as far as I know, are very big models, so I don't know if you can actually fine-tune. I mean, you can fine-tune or pre-train GPT-2, but let me check the examples and also maybe notebooks, because they are more for educational purposes. Transformers notebooks. So all of our examples are here. Let me post this.
Let me copy paste that link. I don't see any other questions, so I'll quickly mention the Hugging Face study group I mentioned. Hopefully, I'll ask more to join in a future one. So
I
please keep an eye
definitely
out.
will join you. Let me go
That's
there.
awesome. So this is the link for anyone that's interested. I'll wait for any more questions. If not, we can wrap up in 30 seconds.
Yeah, sure. You can also ask me your questions from my Twitter, which is or like maybe
I'll quickly.
I'm gonna give my email, but like if you ask it to the Discord or forum, then people will just answer, and which is like we have a very engaging community that people help each other a lot. So you can. It's so weird to look at it.
Please follow Merve at her first name concatenated with the second. I'll drop that in the chat as well. She is quite active on Twitter, and as far as I understand, you reply to every single question there. So I'm sure
Yeah, I try to.
people can connect with you there.
Great, by the way. Thank you so much for hosting me. We should do this more often, and maybe you
No,
should come.
thanks. Thanks to you for your time. And yeah, I would love to collaborate again. I've highlighted Mo's Twitter handle. Please, I would recommend you follow her there. She also shares a lot about tricks around, I think, transformer
That's
models in
well,
general,
in
attention,
general, yeah.
NLP, everything. Yeah, so basically, follow her on there. keep up with the Hugging Face stuff, also join our study group. And with that, I'll wrap up. Thanks everyone for joining, and thanks to you, Mo, for
Thank
the awesome
you.
presentation.
See ya.